Hi! In this video, I'm going to simplify carbohydrate analysis as we will learn methods to determine or quantify carbohydrate in foods. Before that, what is the need to know how much carbohydrate is in a specific food? Carbohydrate analysis is necessary to inform consumers like yourself to allow you to make informed choices about your diet. Okay, so let's rewind back to some basic chemistry. We all know that based on the number of monomer molecules, dietary carbohydrate can be classified into either monosaccharides, oligosaccharides, or polysaccharides. Another fact that must be kept in mind when viewing carbohydrate analysis is that the majority of carbohydrates are reducing agents. What this means is that the carbohydrate can react with other components to yield precipitates which can be quantified. Don't worry, later we will go into more depth on this reducing sugar. So generally, chemical methods to quantify carbohydrate can be divided in three main groups, which are titration, gravimetric or colorimetric, but these methods are only able to measure monosaccharides and oligosaccharides. The first method we will look into detail is the Lane-Eynon method. Lane-Eynon method uses a titration method to determine the concentration of reducing sugars in a sample. To elaborate, reducing sugars are sugars which contain free aldehyde or ketone groups, enabling them to react with reducing agents. So as you can see in the figure, most sugars such as glucose, fructose, galactose, they all contain free aldehyde or ketone groups. In contrast, sugars like sucrose do not have this OH group attached to the anomeric carbon. In this case, sucrose must first be hydrolyzed into a reducing sugar. Only then can it be analyzed using this method. Now, let's take a look at the principles of this method. The basis of Lane-Eynon is the reaction of our sample, the reducing sugar, with two solutions, copper sulfate solution and alkaline tartrate. So commonly, scientists will use Phelan solution, which contains our copper sulfate solution, together with alkaline Rochelle, a type of alkaline tartrate. The mixed Phelan solution is going to be boiled for a specific time, and this boiling is done throughout the process, which is crucial to exclude air from the reaction. Methylene blue will then be added, which acts as an indicator, and our carbohydrate solution will be titrated with this blue phthalic solution until discoloration occurs. The volume of sugar solution required to reach the endpoint will be recorded, and from here, appropriate calculations can be done to determine carbohydrate. However, when we want to use this Lane-Eynon method, there are several drawbacks that must be considered. Despite the cost effectiveness and simplicity of this method, Lane-Eynon is unable to distinguish different types of reducing sugars. It also heavily relies on precise reaction times, temperatures, and reagent concentrations. Therefore, these parameters must be carefully controlled in order to produce accurate results. Moving on, let's take a look at our next method, the Phenol-Sulphuric method. Phenol-Sulphuric method is an example of a colorimetric method which determines the total concentration of carbohydrate present in food, meaning it can analyze both reducing and non-reducing sugars. In fact, Phenol-Sulphuric is regarded as the easiest and convenient method amongst all the other methods used for carbohydrate analysis. It is greatly applied to measure contents of neutral sugar in oligosaccharides, proteoglycans, glycoproteins, and glycolipids. Without further ado, let's study the principles of this method. First, phenol and sulfuric acid is added to a clear aqueous solution of the carbohydrate to be analyzed. This will cause the carbohydrate to be dehydrated into furan derivatives. Following this, a yellow-brown colored product forms as a result of the interaction between the carbohydrates and the phenol. Using a spectrophotometer, this solution is read at absorbance of maximum 490 nanometer, which is proportional to the initial carbohydrate concentration in the sample. The addition of a strong sulfuric acid earlier allows all the non-reducing sugar in the sample to be converted to a reducing sugar. Now, the total amount of sugar present can be determined with a calibration curve by comparison. Once again, with any method, several advantages and disadvantages comes along with it. So this method, it is advantageous because it's able to determine both reducing and non-reducing sugars. Additionally, reagents used in this procedure is expensive and they are readily available with minimal equipment needed for the analysis. Under proper conditions, Phenol-Sulphuric is said to provide the most accurate results to ±2% error. The only disadvantage of Phenol-Sulphuric is that this method is non-stoichiometric, which means that there is a need to prepare a calibration curve. That's it for today's video. Thank you!